Okay, I need you please to title this FDBI notes, as to not use with the homework of FDBI that you're going to be turning in later. This is notes. Okay, now, I need to explain to you what this means. The acronym FDBI stands for Functions Defined by Integrals. Look at this function right here. It says h of x equals an integral. That's kind of strange, because usually integrals with these kinds of numbers on them give you areas. Okay? But that's what this is doing. First of all, this is off of an AP exam. It is off of the 1995 exam. It was on the AB exam. It was problem number 6. There are 6 free-response questions on every AP exam. 4 of them are no calculator, 2 of them are calculator. This one being at the end of the 6 is going to be a no calculator question. So this is going to be all done without a calculator. Now, we have this graph with some very distinct points on it. Okay? It says the graph of a differentiable function f on the closed interval from 1 to 7 is shown. So you need to write out to the side this is f, because we're going to be going back and forth between letters either f and g or f and h, depending on the problem. Okay, so let h of x, here comes this h, be defined as the area from 1 to whatever you choose for x under the function f. Okay, I want you to chew on that mentally for just a minute. H of x is equal to the area under the curve from 1 to whatever you choose x to be under the curve of f. So what I want to do for just a minute is I want to make a t-chart. This is x, this is h of x, kind of to show you what's happening here. Okay? If x, it says x starts at 1. So if I put a 1 in here and a 1 in there, what's the area from 1 to 1? 0. So the y value would be 0. Does that make sense? What about 2? When I put a 2 here, that means that the y value is supposed to be the area from 1 to f. So I'm looking just at this. What would you guess that would be about? About 1.5, right? Because 1 square is 1. So that's about 1.5. Do you agree with me? 3. That means it's the area from 1 to 3. What would you guess that area would be? About 3. A little bit less than 4. Let's round it up to 4. Okay, let's round it up to 4. Okay? Now, I could keep going. Could I do points in between? Could I go from 1 to 1.5? Or from 1 to 3.5? Yeah, I could. So each of these y values is the area starting at 1 and ending at that x. Okay? What about to 5? Is that going to be pretty big? What happens when I go past 5? What's going to happen to these y values? They're going to start getting smaller. Will they ever get negative? No. They will never get negative. They will get larger and then they'll start getting smaller. So if I graphed these points and connected them along here or wherever they are, it makes a new function, and that function is h. Okay? So that's what this means, is the area from 1 to whatever under f. Okay? So let's start answering the questions they're asking about h. We're going to do these. Some of them we can fit in here, some we're going to have to do at the bottom. So we just did this. What is h of 1? It is the area from 1 to 1 under f. And we said that was equal to what? 0. So find h of 1. H of 1 is 0. Usually if it asks you to find h of something, you're going to need it later. Okay? Now, here's the question. What is h prime of 4? Well, that's a little strange of a question because I don't know anything about h prime yet. I know that this is f, but I do know this is h. So if that's a function, I should be able to take its derivative. Okay? So over here, I'm going to write down what h of x is. Again, I'm going to recopy this problem. H of x is the integral from 1 to x of f of t dt, which means the area under f. If I take the derivative of the left side, I also have to take the derivative of this side. And the way I write it is to put the d over dx in front of it. 1 to x, f of t, dt. I took the derivative of the left, and I just took the derivative of the right. Have you seen this before? Please tell me you have seen this before. When you take the derivative of an integral? Yes. What do you do? What's the short way? What's it going to equal?
Plug in the x.
Plug in the x. So h prime of x equals what? F of x. Oh. Okay. So this graph f is actually also the graph of h prime. Okay?
Which makes sense because derivatives and antiderivatives are inverse.
Exactly, because of the fact that they're inverses of each other. Now, so this question now says, what's h prime of 4? Well, if h prime of x is equal to f of x, h prime of 4 should equal f of 4, right? And f of 4 is 2. How did you get that? That's the graph of f. Look at the graph. What's the y value at 4? At 4, it's equal to 2. Right there, that point. Are you with me? Told you it was a mind bender. Okay, part C. I have to do this one down here. On what interval or intervals is the graph of h concave up justify? I like to circle the word justify to remind myself that when I get to that point, I've got to either show work or write a sentence. Okay? Now, I want to know, and I'm going to start doing this. I think it makes it easier. Summarizing what I'm finding. I want to find where h is concave up. Okay. I know that this is h prime, and I need you to think with me. H is concave up where h prime is what? Okay, I think there's two possible choices that your brains are thinking. Positive is one of them. Anybody thinking anything else? Increasing. Okay? So, let's do a number line to kind of prove it to ourselves. When we do a concave up number line, what do you usually write out to the side right here? H prime, H double prime, or H? H double prime goes right there. And concave up, what symbol has to be on this graph? It has to be a plus sign, right? Okay? If this says H double prime, the one underneath it is always one derivative down. So that means this would be H prime, right? One derivative down. What symbol goes under a plus sign? Increasing, right? Now, can this be positive? Is H prime positive? No, H double prime is positive. So it's not positive, it's got to be increasing. That's another way to think through it. Well, it's either going to be positive or it's going to be increasing. It can't be positive because H double prime is positive, not H prime. H prime is increasing. Okay. So, this is the graph of H prime. I need to know where it's increasing because that's going to tell me where H is concave up. Where is this graph increasing? From where to where? 1 to 3. Any place else? And 6 to 7. The justification is this sentence right up here. The justification is the sentence I wrote. Okay. Okay. Now, part D. Now, I'm going to do something a little different. I'm going to fold like I did once before, so bear with me just a minute. Let's do it this way. Bless you. That way I can keep it zoomed in. Okay. I need to look at the other page. I need to unfold it for a second, and then I need to fold it back. It says, find the value of x, so I'm supposed to end up with an x value, at which h has its minimum on the closed interval from 1 to 7, and justify. Okay. So I'm going to summarize that right here. For D, I need the minimum of h on the closed interval from 1 to 7. Minimum of h. Okay, if the interval is closed, listen carefully to my question. If the interval is closed, is that a relative minimum or an absolute minimum? What do you think? That is absolute. An absolute minimum, let me write ABS under here. Absolute minimum means no number line. You don't use a number line when you do absolute minimum. Okay? We have to do it another way. So now I need you to think back. Absolute mins and relative mins. You start the problems the same way. What do you do first? Okay, we look at the endpoints. That's very true. And what else do we look at? The derivative, which is h prime, you set it equal to 0. I don't care whether you're doing absolute or relative. You always set the derivative equal to 0. Only for the absolute do you look at the endpoints. What are the endpoints of this? 1 and 7. So we know it's going to be either x equals 1 or x equals 7. Now, where does h prime equal 0?
3 and 6.
Okay, is it 3 and 6 or is it 5? This is the graph of h prime. Where does it equal 0? At 5 and 7. Do you see what I'm saying? Okay.
How do you know it's the h prime?
Because you're supposed that this is h prime?
Yeah.
Because right here I proved that h prime and f are the same thing.
Oh.
Okay? So as soon as I proved it, I wrote it up here so I don't forget.
No, I don't remember that part.
Okay. All right. So here are my candidates. But I also need to check and see, does h prime fail? Shh, y'all, listen. Does h prime ever fail? This graph failing would be like a hole or an asymptote. Do you see any holes or asymptotes there? No. Okay. So, who remembers, if I don't do a number line, how do I find out which one is the minimum? Plug them into the original equation. So I need to plug these into h. h of 1, h of 5, and h of 7. Now, in the work that you've already done, have I done any of those?
1.
H of 1. What is h of 1? 0. Okay, since I already did the work, I don't need to show any work. H of 5, remember, is the area from 1 to 5 under f. 1 to 5 f of t dt. Okay, so I'm going to put my pen down. From here to here, can you estimate that area for me in squares? 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. A little over 7. 7 and a little bit more. So let's call it approximately 7. Or you can put 7.3 if you want to. 7.5 if you want to. Okay? H of 7 would be the area from 1 to 7 under f. And that would be approximately equal. Approximately, it doesn't come out very well. What would that be approximately equal to? What is this going to do to that total up to this point? Take off about how much? 1. 1-ish? 1.5? You write down what you think it is. It's going to be like 5.5 to 6, somewhere in there. Okay? So, which one of those three is the absolute minimum? H of 1, which is 0. So, the question said, did it ask for the x value or the y value? It said the x value. Value of x. So, the x value of the absolute minimum is x equals what? 1. The work that you did here, this is the justify. That's the justify right there. Because you showed the work of how that was the smallest of the three. Okay?
I don't even think you need to do all that work to find.
Okay. How else could you do? There is actually a way that you can do it without doing all that work.
I thought that the absolute minimum was the lowest point on the graph. I thought it would be a standard pressure.
Okay, that's the absolute minimum of f. The absolute minimum of h. Now remember that h. Okay, let me explain it this way. Remember that h is defined as area. If you're calculating area from 1 to wherever, where is the smallest area going to be? The smallest area is going to be here, because after that point, the area is just getting bigger. Then it gets just a little bit smaller, so the smallest area is right there at 1. Okay, Now, if you could write that in a sentence to where you explain that you know that the is that, you could actually get around doing all that math. But it better be good. The math proves it better. All right? So, any more questions before we move to the back? Okay, flip this over, please. Let's do another one. Okay. Sorry, the top's cut off a little bit, but we can survive. The graph of a function f, that is an f, so write an f right there, consists of a semicircle, so that's definitely an exact semicircle. So in other words, if you had to find area under it, you could know it's a circle. And 2 line segments, so these are straight. Okay? As shown. Let g be the function given by the integral from 0 to x of the area under f. So starting at 0 and going whichever way. G is the area from 0 to whatever. Okay? So part A. This is a rather lengthy problem. This is longer than a standard AP question, I'll tell you that right now. It asks you for g of 0, g of 3, g of negative 2, and g of 5. And you may think, oh my gosh, why do I have to do all those? Because you're going to need them later. All of them, you will. Okay, g of 0 equals, some of you already know, it's the area from 0 to 0 of f of t dt, which is 0. G of 3, area from 0 to 3 of f of t dt equals 0 to 3. So that means this quarter of a circle plus this teeny tiny half triangle at the bottom. Yes, you would. Okay? You would subtract the 2. Now, this quarter of a circle, how do you find the area of a quarter of a circle? 1/4 pi r squared. What is r in this case? R is 2. Squared. And because this triangle is below the x-axis, we have to think of its area as being negative. What is the area of that little triangle down there? Just stopping at 3. 1/2. So it's minus 1/2. How does this quarter circle clean up? What does it clean up to be? Pi. So the answer is pi minus 1/2, and that's considered a valid answer. The area, this is pi. You may want to go ahead and write that in there because you may need it later. So it's pi minus 1/2. Are you with me? Okay. Next one is g of negative 2 equals the integral from 0 to negative 2 of f of t dt. Uh-oh. Why did I say uh-oh? I have to switch them. They're backwards. So what does that do? It makes it negative from negative 2 to 0 of the area under f. So if I go from negative 2 up to 0 and find that area, what's the area of this little quarter circle going to be? That's pi also, isn't it? But because of the negative in front, because I had to switch them, it's really negative pi. Does that make sense? I switch the limits, which may be starting out negative 2 and go up to 0. It's above the x-axis. So it itself comes out positive, but because I had to throw a negative in front of there, it really makes it negative again. Okay? Now, g of 5 equals, I want you to work with your table, and I want you to find g of 5 right now. Work with your table and see if you can get it. Area from 0 to 5, f of t dt equals. I'm not going to walk around and give an answer. I want you guys just to work on it. All right. Jacob, what'd y'all get over there?
We got pi minus 1/2.
What about the rest of you? Did you get pi minus 1/2?
Pi minus 1/2.
Okay. Who can explain why the answer from going to 3 is the same as going to 5?
Just 3 to 5 cancel.
Because 3 to 4 is a negative 1/2, and then 4 to 5 is a positive 1/2, and you're correct, they cancel. The two areas cancel out. So stopping at 3 to 5 is the same thing. Any questions on that? So you're okay doing that part. All right, part B. Moving on. Find all values of x on the open interval from negative 2 to 5 at which g has a relative maximum. So we want the relative max of g on the open interval from negative 2 to 5. I'm summarizing what we're doing. Relative max of G from -2 to 5. Relative max means number line. Open interval means number line. Okay? But what do we do first? How do we find what to put on that number line? I know I'm going to need a number line over here. Not G double prime. What do we always set equal to 0? G prime equals 0, right? Okay, think back to when we learned maxes and mins. What do we do first? We take the derivative, set it equal to 0, right? So, because it's of G, it's G prime. Okay? Now, G prime, I don't know what G prime is. Okay, let's see. Is G prime equal to F? Come back here for a minute. G prime, oops, I didn't mean to do that. G equals the integral from 0 to x of f of t dt. So if I take the derivative of this, doesn't that mean I take the derivative of the integral? Yes. So d dx, integral 0 to x, f of t dt, so G prime is equal to F, just like we did on the front. So F up here equals G prime. I know it's right behind the recording button. I'm sorry. There.
There will always be something like that as well.
Yes. On these problems, there will always be something like that. And you have to, now, you either have to prove it mathematically, or you have to write G prime equals F by the second FTC. You can just write by second FTC if you see that, and that's good enough. Okay? So, if this is the graph of G prime, where does it equal 0? -2, 2, and 4. You agree with me? Okay? One of those needs to be thrown out. Which one and why? -2 needs to be thrown out. Why? Because it's an open interval. You can't use -2. Throw that out. So that tells me I'm supposed to put 2 and 4 on the number line. Okay? Now, I may need to put something else, because I need to know if this graph fails. Does the graph fail? Not the derivative. Does the graph fail? Is there any holes in the graph? Any asymptotes in the graph? No. So, those are the only 2 points we're going to use. Okay. This is the number line for G prime. What symbols do we usually write up here? Pluses and minuses. This is G. Up until you get to 2, what symbol should I use? What kind of, is that plus or minus? Plus means above the x-axis. Positive, this is G prime. Is this graph positive until you get to 2? Yes. So you may want to write above x-axis to remind yourself. That's where I got a plus sign right there, above x-axis. What about from 2 to 4? What is it? It's negative, isn't it? And then after 4 it is positive. Okay? So that tells me that G is doing what? If this is positive, what's G doing? Getting bigger, increasing, then decreasing, then increasing. I'm looking for the max. Which one is the max? 2. Now, I forgot to circle something very important up here, and that is the word justify. Okay? A decision was made several years ago that number lines are not justification. Because some people can put symbols on a number line and say that that's a max, but not completely understand why. Okay? When you do the endpoints, and when we did the one on the front, when we said, oh, that's the smallest y value, that's obvious that that's justification. This is not enough. We got to write a sentence. And it's the same sentence we've been writing all year long. How does it start? Since G prime from, okay, no, this is G prime. It's changing from positive to negative. Isn't that what it's doing on G prime? At x equals 2, there is a relative max at x equals 2, period. Okay. That sounds like a great sentence. Now go back and look at the question. It says find all values of x. Did we address x? Yes, we did. So that's the answer right there. Okay. Any questions on that? All right. Part C. Now I'm going to have to fold my paper again. Oh, it's already folded for me. Isn't that nice? Is everybody done writing this down before I fold? Are we good? Okay. Bear with me. Part C. Find the absolute minimum value. Ooh. What did value mean? Y value. So I'm going to write a Y right there to remind myself. Of G on the closed interval from, closed interval, -2 to 5. Oh, and the value of X at which it occurs. So I need both the X and the Y. And then it also says to justify. Okay. So let's summarize what we're doing. Absolute minimum of G on the closed interval from -2 to 5. There it is in simple English. Simple abbreviation. And I got to justify. Okay. We did an absolute minimum on the front of this document. If you need to go back and look, what did we do first? We set the derivative G prime equal to 0. Now, didn't we just do that in part B? Yeah, we did. So we do, X equals -2, X equals 2, X equals 4. We already did that. Just copy them down again. Now, do I need to throw out anything? I don't throw out -2. But you know what? I know for a fact that 2 cannot be the answer. Does anybody know why? Because it's the max. If 2 is the max, it's not going to be the min, right? So I can throw that out and say this is the max. So I don't need it. Okay. So, -2 and 4. Is there any other point that might be the minimum? 5 might be. So write down the 5 because it is the end point. You've got to use the end points. -2 is the other end point. Okay? Now, if you don't remember, look on the front. What did we do? We did not do a number line because you don't do number lines with absolute.
Is 5 the same thing as 2 though?
No, 5 was the same thing as, this is a different graph. 5 and 3 were the same thing, not 5 and 2. Okay, we're going to plug them into the original equation. So I need to know G of what? -2, G of 4, G of 5. Well, guess what? I've already done some of those in part A. What is G of -2? We already did it. -pi. Which other one do we already know the answer to? 5. What's G of 5? Pi minus a half. So far, which one is the minimum? -2. Okay. G of 4. Haven't done G of 4 yet. Look at the picture. Can you figure out what it's going to be? What's the area from 0 to 4? Pi. What's this? -1. So this is going to be pi minus 1. Okay. This is sufficient justification right here. This is the justify. Okay? But now we need to address the question in the way it was written. The absolute minimum value. The absolute minimum value is which one? -2 or -pi? -pi, because it's the y, comma, which occurs at x equals -2, because it said find the absolute minimum value, that's the pi, and the value of x at which it occurs. Done. Bless you. Okay. I know this is a lot. Just bear with me. These last two are not that bad. Or is it 3 more we got to do? 3? Okay. Sorry. D. Write an equation for a tangent line. Ooh, we haven't done anything like that in a while. To the graph of G at x equals 3. All right? So, what should our answer look like? Y minus something equals something, parentheses, x minus something. Okay? I'm going to fill in everything that I need. Okay? I already know one of those 3 blanks. Which one do I know? X is 3. Okay. Okay? Now, what goes here? What is the y value that goes with 3? No, it's not. Okay, this is the equation to the tangent line of g, so I want to know what g of 3 is. Oh, I figured out g of 3 in part A. What is it? Pi half, and you need to put it in a parentheses. So what is this negative 1 that's here? Isn't it on the g prime equation, on the g prime graph? That's the slope. That's g prime. So that goes here. Because this is the graph of g prime, doesn't g prime of 3 go right there? Okay? Let me give you a big hint. If you're given a graph on an AP test or on a test in my class and a point is labeled, you're going to need that point for something. This is where I need it. Okay? They don't label stuff arbitrarily. They label it because you need it. Okay? So, that's done. There's my answer right there. Okay? Now I'm going to have to fold my paper again. Letter F is going to need like just a little bit of space. I'm just telling you now, so bear with me. E will take a little, about as much room as, not as much as C, but not as little as D. Come on and fold it ready. Here we go. E. Okay. E. Find the x-coordinate of each point of inflection, POI, of the graph of G from -2 to 5, and justify. Points of inflection. Ugh. Okay. When we find points of inflection, don't we usually draw a number line? Yeah. So let's put a number line on there. Which number line is that? Double prime. G double prime. Okay. Because points of inflection are always found off the second derivative.
That is correct.
Okay? All right. Now, have we talked about G double prime at all?
Yes. Wait, no.
On this paper? No, we haven't mentioned G double prime at all. Okay, but let me show you the progression here. G prime is the same as F, right? So what is G double prime the same as? Very good. Which means the slope of F. The slope of that equation. Okay? So I need to know where G double prime equals 0. Where does the slope on that thing equal 0? Wait. Yes. I'm sorry. I misspoke. How do you get 0? It's like a max. Isn't the slope up there 0? Yes. So it's x equals 0. Now, the slope down here really isn't 0, but it's like a min. It's where the slope fails. So that's another critical point. So those are the numbers that go on here, 0 and 3. Okay, I need to give you a worksheet real quick. Then put that in your stuff as well. Okay. Now, here's where it gets a little bit interesting. To the left of 0, I want to know what the slope is doing. What is the slope doing as you approach 0? Okay, let me rephrase that. What sign is the slope as you approach? It's positive because the graph is increasing, agreed? So this is a plus because the graph is increasing. Then from 0 to 3, what's the slope? Negative because the graph is decreasing. And then it is positive again because the graph is increasing. So, what has to happen in order for these to be points of inflection? Are they changing? Yeah. Prime, right? So, POI at x equals 0 and x equals 3 because you got to justify, and you have to use the graph, G prime. What is G prime doing? No. G prime is not changing sign. It is changing direction. G double prime is changing sign. Okay, almost done. I know, but the bell's going to ring pretty quick. This last one is rather simple. Find the range of G. Okay? Range is Y's, right?
Yeah.
Now, would you agree that the range would be from the minimum to the maximum? What do you think? Wouldn't the range be from the minimum to the maximum? Okay. You've already found the minimum, haven't you? Do I want the X's or the Y's? Y's. Look back at your minimum problem. That was part C. What was the minimum? Negative pi, right? Okay. Now the maximum was part B, but we didn't find what the maximum area was. What is the maximum area at 2? Because 2 was the answer. Answer is pi. That's the answer right there. We're done. Okay. Now, I know your brain is tired. I know it is.